All right, y'all, we are going to be jumping into our statistics chapter. Woo-hoo. So, chapter 8 is all about statistics. And what we're going to take a look at first is some ideas for the base of statistics, which is talking about how do you gather and organize data. Okay, so a lot of times when we think about statistics, we think about 70% of all statistics are made up on the spot, or we think about maybe MLB statistics or NFL statistics or things like that. But how do we actually figure out what those statistics are? Another example would be like if you're told that a college has a 13 to 1 student teacher ratio, what does that mean and how do they figure it out? So, what we're going to look at today is distinguishing among those sampling techniques, organizing the data using an appropriate method, and then also creating frequency distributions. So, a couple of vocabulary things I want to point out here, okay, is talking about a sample, units, and data. So, a lot of times, what we hear about when we talk about a sample, okay, is the difference between a sample and a population. So, a population is the entire group of people we want information about. Okay, so if we think about the population of, let's say, Hendersonville High School seniors, right? That's every single senior at Hendersonville High School. If we think about the population of Henderson County, that is every single person that lives in Henderson County. If we think about the population of the geese that live on the pond here at Blue Ridge, that is every single goose that lives here at Blue Ridge. So a lot of times it'd be nice to know information about a whole population, but it's not really logical to get it. So when we are able to get information about an entire group of people, it's what's called a census. Okay, a lot of times since performing a census isn't feasible because it's going to take too much time, it's going to take too much money, it's going to just be too much brain work. Even if we're talking about just Hendersonville High School seniors, right? That's maybe a group of like 250 students. I don't actually know how big Hendo is, but say 250 students. But still tracking down every single one of those students and asking them a question or asking them to respond to something can be very difficult and time consuming. Or if we're talking about the U.S. Census, right? So the U.S. Census is done every 10 years. By the time we're able to analyze the data that comes from those 10 years, it's basically no longer necessary. Now, what we then do is we figure out, okay, well, what's a good sample that can represent this entire population, right? So what's a subset of the population that can represent the whole group, right? So a sample, much more reasonable to get, right? Sample, I can ask 20 people that might be representative of the whole, and that should tell me kind of everything that I need to know. You can see that it says a group of units. Units are anything that can be measured or surveyed. And then data is the observation that we make on those units. Okay, so units, again, you're going to hear, it might be that it's every, otter that lives in Western North Carolina, or the sample of the otters that live in Western North Carolina. It could be plants, it can be objective experiments and other things. And then the data is how do we observe the units. Okay, and so this goes back to talking about the idea of a population. So the population is the collection of all the units that the gatherer is interested in. All right. So because we can't always do a census, because we can't always figure out information about every single individual in our population, what we can do, okay, is we can get a sample. But how do we generate a good sample? Okay, so what I mean by that is, let's say you're interested in all of the people in Henderson County that like books, okay, that like to read. So you decide you're going to stand outside Hendersonville Library, and you're going to stop every person walking into the library and ask them if they like books or if they like to read. Well, that's probably going to give you the answer that you want. You're going to figure out that everyone in Henderson County likes to read. Why? Because they were walking into a library. Okay, same thing. If you're standing outside a movie theater asking everybody that's walking in if they like movies, you're going to get overall that everybody likes movies. because that's where you set up your sample. So that's not a good sampling technique. So let's take a look at some that are good. So a simple random sample, okay, the easiest way to think about this is what I like to say is names and a half. Okay, and we abbreviate this SRS. Okay, so what that means is if we want to do a sample on every senior at Hendersonville High, but we know that we're not going to be able to get to all of them, let's put all 250 seniors' names in a hat, draw out 30 of those names, and go ask those 30 students whatever it is we need to know. Okay, so everybody has an equal chance of being selected. Another way to do this is to number everyone in the population and use a random number generator to figure out which student you're going to, or person unit you're going to. So an SRS, the easiest way to think about that is names and a half. The next one that you have is systematic. Okay, so systematic, the way that I choose to think about this, so it says it's selected from an ordered list of the population. The easiest way to think about systematic, okay, is you're going to start at, let's say, the third name on the list. And select every 15. Okay, so you're starting somewhere, wherever you want to start on the list of names, and then you're choosing every whatever person. Okay, so you could start at the 15th name and choose every 10th person. So you're following a system that you as the researcher choose to set up. Okay, the next one that you have is a stratified sample. Now strata is a little bit different. Okay, so stratified, I'm going to come down here for this. You're going to split them into groups based off a shared characteristic. And then you're going to do an SRS within each group. Okay, so let's talk about what that means. Okay, so when we talk about stratified sampling, you're splitting the initial population up into groups, okay? So again, I'm going to refer back to thinking about a high school. Okay? So if we're thinking about a high school, one of the easiest ways to split students up would be by their grade level. So let's say we're talking about East High. You want to know how many students are in favor of having 20 extra minutes at lunch. And you want to make sure you get the right group of people. So what you're going to do is split East High up by freshmen, sophomore, junior, seniors. And then within those groups of their classes, you're going to maybe select 15 from each class to tell you their opinion. So you split them into groups first, and then you do an SRS within each group. Another way, just to think about stratified, like if we're talking about Blue Ridge, okay, and let's say that they want to ask staff, should we get, I don't know, an extra hour off during the day, something like that, okay. Let's say that that's their question. Well, maybe they split the staff members up by people that have been here 1 to 5 years, 6 to 10 years, 11 to 15 years, so on and so forth. Split them up that way, and then survey, 5 or 6 from each of those age or time worked groups. Okay, so stratified, you're going to split them up first, and then do an SRS within each. And then the last one we have is called a cluster sample. Now, the biggest thing to think about with cluster sampling is it has to do with location. Okay, so cluster, location, location, location. So what I mean by that is, let's say, same example as before, okay, you still want to know if staff want the extra hour off or whatever. And so what you do is you split Blue Ridge up by building, okay? So you split us up by, Patton, Henderson, Ted, Spearman, so on and so forth. And then after you split us up by building, you randomly select 2 buildings and you go and you survey every staff member there, okay? So go and interview every single person that's there. Don't let anybody leave. Make sure you get everybody. And so when we talk about cluster sampling, it's all based off of location. It's also that you pick people in large groups. So another way to think about it is like if we think about the Asheville Mall, okay? So you split the mall up by stores. You randomly select 2 stores, and you go and you ask every single person that's in that store at that moment, whatever your survey question is. Okay. So cluster sampling, again, location. Stratified, you're splitting them up. Systematic, you're following a pattern. And SRS, you're doing names and a half. All right. So for the following situation, identify whether the simple is a simple random sample, systematic, or stratified, cluster, or none of these. So a postal inspector wants to check on the performance of a new mail carrier, so she chooses 4 streets at random among those that the carrier serves. Every household on the selected streets receives a survey. Okay, so looking at this, right, if you want to pause the video, take a second to think about it on your own. But looking at this, she randomly chooses 4 streets at random, and every household that's on those streets gets a survey. So this would be considered a cluster sample. So again, we split them up by location. So what her locations were the streets that she serves. And then you randomly select however many. In this case, she picked 4, and you survey every single individual within that location. So in this case, it was a whole street. So she's surveying every house on 4 different whole streets. All right, same thing. An executive at a streaming service wants to know if her subscribers would support a second season of a new show. She gets a list of all the subscribers who have watched at least 1 episode of the show and uses a random number generator to select a sample of 50 people from the list. So take a second, pause, and see if you have your idea. All right. So we see random number generator, right? So that means, okay, at some point an SRS was done. Okay, so at some point they performed an SRS. Now remember, an SRS can be on its own. It can also be in conjunction with stratified sampling. So let's see if we can figure out if this could be stratified sampling. So when we take a look here, she gets a list of all subscribers who watched at least 1 episode of the show. Okay, so she did split, technically she had them split up into people that have watched the show and not watched the show. However, the issue with this sort of setup, okay, is that she's only surveying the people that have already watched 1 episode of the show. Okay, right, so the issue with this would basically be that it's kind of like the convenience bias we talked about when you're standing outside the library and asking them, you know, do you like books, right? So this is an example of poor sampling. So it's none of our good sampling techniques. And again, the reason being is because she's taken it down from all of the people that have subscribed to, let's just say, Netflix, okay? Then from there, she's found all the people that have watched at least 1 episode of Wednesday, and then she's contacting 50 of those people who have watched at least 1 episode of Wednesday to ask if they want another season. Okay, so she's skewing the results in her favor. Now, if she had, done the same thing with stratified sampling, split the groups up into people that have and have not watched an episode of the show, and then surveyed, let's say, 50 to 100 within both of those, okay, we can work with that. That's stratified sampling. But because she's only focused on the people that have watched 1 episode of her show, it's skewed. All right, so we've already talked about this one. I should have looked ahead and realized that I already have this one. So again, standing outside the movie theater, asking if people like movies, and yeah, that's sampling. All right, so those are our different types of sampling techniques. The next thing that we want to look at is, okay, once I've run a sample, what do I do with the data? I have the data, now what do I do? And so once data has been collected, we turn our attention to analysis. So the first thing that we look at is the difference between the two types of data that we'll run into. So categoric data puts the group in a unit into a group. Quantitative data is a numerical measurement of a property of a unit. A lot of times you may also see categorical called qualitative, because you're looking at a property or quality of the units. And you might also hear quantitative called numeric. Okay, so those are kind of the two types of data that we can look at. And so when we talk about categoric data, this would be something like you get a response to what color is the car you drive, right? The response is going to be something that is categoric or qualitative, right? I drive a red car, you drive a blue car. So the response is going to be some sort of categoric response. And something to think about when we think about the difference between categoric and quantitative data is, does it make sense to average these values together? Okay, so what I mean by that is, we're looking at people's car colors. Does it make sense to average red and blue? No, that doesn't make any sense. Why would you take the mean of two colors? Okay, but when we talk about quantitative data, how many classes are you taking this semester, right? So you're going to get a numeric response, 2, 3, 4, 5, whatever. And then if we average all those together, well, we can figure out, okay, what's the average number of classes a student at Blue Ridge takes? So that's kind of the difference between those two. One quick note about categoric data, just as an FYI, you can have categoric data that is represented in numeric form. So it's not always as simple as, did I get a word response or did I get a number? The unique examples of those would be something like, for categoric data that's still represented as a number, would be like postal codes or zip codes. Right? It doesn't make any sense to average the zip code of Laurel Park and Hendersonville together, right? That doesn't do anything for us. Another one would be area codes, like the 3 digits before a phone number, like 828 and 704. Doesn't make any sense to average those. So it's not always as simple as just looking at, is it a number or is it a word, and deciding the difference there. Next up, we have what a categoric frequency distribution is. And so that gives you all the categories present in the data and then how often they occur. And then a bin frequency distribution groups the data into ranges called bins and then reports the number of responses in each bin. So let's take a look at this. A teacher records the responses of the class, 28 students, on the first question of a multiple choice quiz with 5 answer responses possible, A, B, C, D, and E. Create a categoric frequency distribution that organizes the responses. Okay. So we're going to say responses and frequency. So the responses that they could possibly be given would be A, B, C, D, or E, based off what the teacher said. And so then you're just going to go through and you're going to count up how many A's, B's, C's, and D's there were. So for A's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so 14 students responded with A. For B, let's see if I can change colors. We got 1, 2, 3, 4 B's. For C's, we got 1, 2, 3, 4, 5, 6. For D's, looks like nobody answered D. So then our response here would be 0 for our frequency. And then for our E's, we got 4 E's. So once you create the frequency distribution as well, you want to make sure that you didn't miss anybody. So what we want to do is just add up those frequencies. So 14 plus 4 plus 6 plus 4, that gives us 28 students, and that teacher had 28 students. So categoric frequency distributions, you're probably pretty familiar with. I mean, this is like old school, what's everybody in the class's favorite pet type thing. And so that's what we're kind of taking a look at. All right, and then for this one, attendees of a conflict resolution workshop are asked how many siblings they have. Their responses are as follows. This one asks us to create a frequency distribution to organize the responses. So take a minute, go ahead and pause the video, take a beat, and I want you to try figuring out what that frequency distribution would look like. Hopefully you've paused the video, because I'm going to start going over the answer. If not, pause the video. All right, so looking over this distribution and the responses that they could give, looks like people had 0 siblings all the way up to 5. So those are a possible number of siblings. All right, so let's look at how many people had 0. So we've got 1, 2, 3, 4, 5 zeros. All right, let's take a look at our ones. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Number of people with 2 siblings. 1, 2, 3, 4, 5, 6. Number of people with 3 siblings. 1, 2, 3. And then with 4 siblings, looks like we have 2. And then 1 with 5 siblings. All right, and then again, what you'd want to do here is figure out how many people were at this workshop. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across the top and 3 down. So there were 30 participants. And then we want to make sure that we got to 30 over here. So 5, 18, 24, 27, 29, 30. So we're good. All right, so that is how you would create a frequency distribution, and that is it for 8.1. See you soon.